So now in this video, in this assignment, you're going to get a little break from the long, drawn-out processes of algebra. Okay, we're going to do a little street math here. Okay, I want to teach you something different, broaden your horizons a little bit. It means extend out. It's not. These don't take a long time, if you know, especially if you know what you're doing. Now the video here is a little bit different, in that you're going to watch part of the video, then you're going to pause it, then you're going to work on your own, then you're going to unpause it, work on your own, because the problems go pretty quickly if you know what you're doing. Now, this is the packet. You don't have this sheet. You're not supposed to have this sheet. This is me explaining something. So to a certain gentleman in the class, I'm not going to say the name on video, don't turn around and say, well, I don't have this paper. You're not supposed to. Okay, I'm trying to make a point. Sorry about that. So it says to buy lunch, you choose between 3 salads, 2 soups, 5 sandwiches, and 4 drinks. How many lunches are possible? I'm going to write down a couple. So salads, you get a Caesar salad. That's not how you spell that. Who cares? Soup, I don't know. I get chicken noodle. Sandwiches, I can get ham and cheese. And drink, I get a Coke. That's just one possible meal. Okay? Now, next week I can get a Caesar salad again. Let's say instead of chicken noodle, we get vegetable. Instead of a ham and cheese, I get a burger. Instead of Coke, I get 7-Up. That's another possibility. Now, I don't have time to list all those possibilities. It's going to take forever. So to find all the lunches possible, it's called the counting principle. Okay, when you have to make a list with mix them all together, it's called the counting rule. Okay, you can simply multiply your possibilities. So 3 possible salads times 2 possible soups, but I also have times 5 because every new item, I multiply by that number. Okay. Because see, if it was just 3 salads and 2 soups, if soup salad's all I get and I take out the sandwiches, then that's 6 possibilities, okay? But with each one, I add a new factor. So 3 times 2 times 5 times 4, that's 120. So it says how many lunches. We now know there's 120 different lunches a person could create. And that's me creating different ones. I'm not going to make 120 of these. Okay, the next one. To buy lunch, you choose between 7 types of drinks, 8 types of chips, 24 types of sandwiches. So I'm just getting drinks. I have 7 possibilities. But then throw in the 8 types of chips, we multiply by 8, and we multiply by 24. Because 24 is a lot, okay? 7 times 8 times 24, and that's 1,344. A lot of people get confused. Do I add them or multiply them? No, you got to think big picture. Multiplying them increases the number gets the number higher more rapidly than adding does. Okay. Okay, and then right here, to buy lunch, you choose between 3 types of chips, 5 sandwiches, 2 soups, and 3 drinks. How many lunches are possible? So 3 times 5 times 2 times 3. That's 90. Okay, so 90 lunches. You don't even have to show any work on these, okay? Pause the video right now and do the back 2 problems. Okay, hopefully that went pretty well. It's pretty easy. Now here's the next set. An industrial cleaner is manufactured using ingredients. So when you make a cleaner, you put a bunch of different crap in that cleaner. I'm too lazy to come up with the actual names of what you're putting in, like vinegar. That's one thing you can put in. Iodine, that's another thing. So there's 3 different things, and it's mixed in a ratio of 2 to 3 to 5. The colons just mean ratio. What that means is every time I put 2 pounds of A in, I got to put 3 pounds of B in, and then I have to put 5 pounds of C in. If I put another 2 pounds of A, I got to put another 3 pounds of B and another 5 pounds of C. Let's say I want to make it even bigger. I can make it as big as I want. If I put another 2 pounds of A, another 2, then I'd have to go 3 pounds, add 3 pounds of B, and add 5 pounds of C. Okay, and it just repeats itself. So that's what a ratio really means. Okay, now that's what the ratio is by weight. How many pounds of B are in a 42-pound bucket of this cleaner? So it ends with you having 42 pounds of the cleaner, but you got to find out how many of each of these. See, these have to make 42. So here's what I do with my ratio. I put 2 over 3 over 5. Then I make another line and I add these together. You plus them together, okay? So 2 plus 3 plus 5, that's 10. Now label these by letter. That's A, that's B, that's C, and that's total. Put a T for total. The last number is always total. Now make lines that match up, okay? And that 42 pounds is how much you actually have, okay? And that's your total. Now, here's how you're going to find how many pounds of B there are, okay? These all need to be multiplied by the same thing to get to the numbers that are over here, okay? It's called a common multiplier. But you got to find out what the number is that would be multiplied. Well, it's really easy. Just look down here. You take 42 and do the opposite of times, which is to divide by 10. It's got to be divided in that order too. You just go backwards, write this before this, and divide. So that's 4.2. So that means it's multiplied by 4.2 in the whole ratio. Now you don't need to multiply all of them because they just want B. So here's B, 3 times 4.2, 12.6. So 12.6 pounds. Okay, my next one, a solution contains ingredients A, B in a mixed ratio of 2 to 5 respectively by weight. So every time there's 2 pounds of A, you got 5 pounds of B. If you put another 2 pounds of A, you got to put another 5 pounds of B. It's like a balance. You put another 2 pounds of A, you got to put 5 pounds of B. 2 pounds of A, 5 pounds of B. Add 2 pounds of A. You can make however many you want, but every time you add 2 pounds of A, you got to add 2 pounds of B. How many pounds of A are in a mixed of 56-pound solution? So again, take your ratio, put 2 over 5. Then you always make a final line and add those. Well, that's 7. It's not as long as the last one because there were 3 here. There's only 2 here. But you do have to add them when you get to the end. Put them. So make lines that match up real easy. And again, that's A, that's B, and that's total. Now again, what they give me, that 56 pounds, that's your total. So you got to find out what you're multiplying these by, okay? Well, if you don't know that, you can take 56 and do the opposite of times and divide by 7. So 56 divided by 7 is 8, okay? So you're going to multiply all of these by 8, but you just have to find how many pounds of A. So 2 times 8 is 16, and that's your answer. There's 16 pounds of A in the mix. Now you can find B, but that's not what you need to figure out. Okay, gravel contains ingredients A, B, C, and D in a ratio of 2 to 3 to 5 to 8. That means whatever you have in the bucket, if you want more, if you're going to add 2 pounds of A, then you got to come in with 3 pounds of B, 5 pounds of C, and 8 pounds of D. Now you always make a final line and add these. 2 plus 3 is 5, plus 5 is 10, plus 8 is 18. Okay, now make lines so they match up. Now that's 72 pounds again, that's your total because you got A, B, C, D, and then the last one's always your total. Don't put E or something stupid there. You just said A, B, C, D. Okay, 72 pounds is how many we have, okay? And I got to figure out what are all these multiplied by? Well, 18 times this number is 72, so I would divide 72 by 18 to figure out what the number would be. It's like how many 18s are within 72. Well, that's 4. So the multiplier, that's not the answer, that's the multiplier. Now, you don't have to fill all these out, you just have to find D. Okay, here's D. 8 times 4, 32. So 32 pounds. Okay, pause the video, do the 2 on the back. Okay, now here's another piece of street math. The DVD player with at a list price of $100. That means it costs $100. It's marked down 30%. Now, John, our man here, he's going to get an employee discount of 20% off the sale price. How much does John pay for the DVD player? Now, there's 2 percentages, so we're going to work the problem into 2 spaces. Put your $100 here, and if it's marked down, that means you subtract. But the problem is, I don't know how much money that is because it's 30%. Well, here's how we figure it out. We find 30% of what? The $100. Now, it's something we don't work on a lot. It's kind of, I'm sure you did in 8th grade. If you don't remember how to find percent of a number very quickly, you divide your percent by 100 every time. And that's going to be a decimal. 0.3. And the word of means you multiply. So I take 0.3 times 100. That's 30. So 30 is how many dollars are subtracted. 100 minus 30 is 70. Now for the second part of the problem, there's another percent, but the number we now are at is 70. So I drag the 70 over here. That's 20 off, so that's another subtraction. But how much is taken off? Well, I have to find 20% this time of what? Of 70. Here it was of 100, but now it's of 70. So again, I divide the percent by 100, and then 20 divided by 100 is 0.2. And then the word of means you multiply. So I take 0.2 times 70, and that tells me how many dollars I subtract off. So 70 minus 14 is 56. And that's your final answer. If there's a third percent, I'd have to keep going. Okay, next one. An item with a list price of $225 marked 25% off. You have a coupon for 20% off. How much the item cost? Again, with the 2%, we start. It's usually a $225, but then it's marked off, so I get to subtract some dollars from the price I have to pay. Well, how many dollars? I don't know because that's a percent. So I take 25% of what? Of what it costs now, $225. So I divide by 100. That's 0.25. Then again, of means you multiply. 0.25 times 225 is $56.25. Yeah, you can get a decimal because it's money. It's cents, bro. Okay? So 225 minus 56.25 is $168.75. Now, there's another percent off. So I drag this. That's what it costs now. And I'm going to subtract more money. To find how much, we take our second percent, of 168.75. Then divide by 100. You're always dividing that's what a percent is. It's a ratio over 100. So that's 0.2. And then of means you multiply. 0.2 times 168.75. $33.75. That's how many dollars are then subtracted. So 168.75 minus 33.75 is $135. So that's what it costs right now. If they do another percent, then I'd take 135. Okay. All right, last problem. Didn't give you a lot of space here. An item with a list price of $200 marked 30% off. You have a coupon for 15% off. How much the item costs? So what do we cost? $200. And I'm going to subtract dollars from that price. Okay. How much do I subtract? I don't know. I have to find 30% of $200. You got to find the actual dollar amount. Okay, you don't take minus 30% because that's money. You can only subtract and add things in the real world that have the same label. A percent and a money aren't the same label. So divide by 100. So 30 divided by 100, 0.3. And again, of means times. So 0.3 times 200. And $60 is how much I subtract. Okay, so I take 200 minus 60, and that's $140. Now there's another percent we have to deal with. So I drag the 140 since that's what it costs now, and then I subtract again. But I don't know how much money to subtract because that is not money, that's a percent. So we find 15% of what? Of 140 now. So I divide by 100. That's 0.15. Then of means times. So 0.15 times 140 is 21. So now I subtract $21. And 140 minus 21 is 119. Okay, pause the video, do those two problems. Okay, now we're back. That's what this, then the next part is what this other sheet's for. I'm actually going to do these 5 along with you, okay? Now, because this is kind of far out there. The length of a rectangle is 4 more than twice the width. Write an equation for the length. Okay, you're to write an equation for the length. Okay, so your length, put L equals. Equation means equals. Now, go find the word is and block that off. Just separate it and then look after it. You are going to put W on this side, but there's operations around the W, not the L. The L's by itself. Now, 4 more. What's more than mean? Plus. Plus and minuses you put behind that. Then keep reading. Then twice the width. Well, twice means 2, and it means multiplication. Okay? Now, with multiplication, you multiply. You put a dot, but that's in front of your variable. Okay? So L equals 2 times W plus 4. It could also be 2W plus 4. That's good enough. And also on your paper, can you, under twice, can you also put times? Because that obviously means multiply 2. Okay, the length of a rectangle is 3 more than its width. Write an equation for the length. L equals. Now go find is, block it off, because is stands for equals. And then I put W. Well, 3 what? 3 more. More than means plus, so that's from behind. And that's all you have. You don't have any other numbers. Here, twice is a number. Okay, it's 2. But here there are no other numbers, so it's L equals W plus 3. Okay, write an equation for length. Block off is, because is stands for equals. 7 less. Well, less means minus, but I want a minus 7 now. Then 3 times. Well, times means times, but you times from the front of the variable. That's why you always see it written as x is like 3x and not x3. Okay? Pretty easy. Okay, next one. Length of a box, 7 inches more than twice its width. Write an equation for the length. So length is what I'm writing the equation for. Go find the word is, and you put W over here because length and width. Okay. We usually use X and Y, but now the variables change. So 7 inches more. More than means plus, and that's after. Twice its width. Now, twice means 2, and it means multiplication, always by 2, and it's twice. So L equals 2 times W plus 7. Okay, and then the length of a box is 4 less than 5 times the width. Write an equation for the length. So you go find the is, block it off, and then W's over here, but it's got operations with the numbers I see. So it's 4 less. So it'd be minus 4. Then 5 times. Well, times means dot. So it'd be L equals 5 times W minus 4.